Hello all, welcome to my YouTube channel. My name is Gokul, and in this video, we are going to talk about what is machine learning. Machine learning is a piece of program or a mathematical model which just predicts an output based on the current input. At the end of the day, the mathematical model is somewhat like a statistical model. This statistical model, which trains on a huge amount of data, such that whatever future data comes into this particular model, it just predicts an output. The output can be either continuous output or a discrete output. Okay, let's move to the functioning of the machine learning. So we can see here, this is the input phase where we feed the model the required data. And this is the model. This model can be any mathematical model, say for example, linear regression or logistic or any kind of machine learning algorithms. And then this model would produce an output, which is actually the predicted output. And then we have the actual output. And based on this, the predicted output and the actual output will be having some kind of difference. So that difference will be calculated. And with those difference calculated, the model will again fine tune its parameters. So we can simply get an intuition like, for example, I'm running a bank named XYZ, and then I'm having a use case of long status classification for the incoming users based on two features, which is their gender and age. So based upon their gender and age, I would be classifying whether the user can be given a loan or not. This is a sample data set. So here, this gender and age, so both are input, and the status is obviously the output. So in our workflow, so the gender and age will be passed in as input. And then we get the predicted output. Say, for example, for the input male and 21, we get a status of saying yes. Initially, our model is predicted an output of yes, but our actual output is no. So based on this yes and no, we would be calculating loss. So you can think of like we are having a categorical variable, say yes and no, but how we can calculate the difference. So here comes some techniques of ML like one-hot encoding. So in this case, the yes will be converted into 1 and no will be converted into 0. And then this 1 minus 0, which gives me actually 1, is carried out into the last part. And then this 1 is moved on into this model. And then the model just fine-tune its parameters. Say, for example, in this use case, we are having a model of linear regression, which is y is equal to m into x plus c. So this particular m is actually the parameter in this particular model, and this particular m variable will be fine-tuned to just make our output most similar to the actual. And then we are moving to the types of ML. So they are supervised learning, unsupervised, semi-supervised, and reinforcement learning. Supervised learning is actually what I have mentioned earlier. So here, so based on the supervised data, our model will be trained. Supervised in the sense, the data here has supervised output for the gender and age as input. We are instructing the model that for the gender and age, we would be getting an output of status feature. So this is the supervised learning. So supervised learning has actually two parts, regression and classification. Regression in the sense, if you are trying to just predict the price of a house based on the features like the location of the house, total number of rooms. So the regression, the output from the regression model will be like some kind of 20,000, 30,000. So it is a continuous output. So those kind of problems will come under the regression. And the classification part, as we have just visited earlier, the gender, age, and status. So in the status, we have only two variables, binary classification as yes and no. There are also some use cases where we have multi-class classifications, like to classify whether it is 1 or 2 or 3. So it comes out of multi-class classification. And then we get our unsupervised learning. In our unsupervised learning, we only have our gender and age. So we won't be given any status. Our machine learning model will just try to just segregate the data on its own. For example, to think of this as a graph, and in the gender and age, based on this gender and age, we will be classifying the status as yes or no. So here we have two classes. So what our unsupervised learning algorithms will just make is like, based on the gender and age, those will be converted into a mathematical model, and the data would be plotted here. Like, so here we are having two classes, 0 and then x. So 0 here is yes, and x here is no. So without the use of any target variables, we just able to classify the data points as yes and no. So this is what unsupervised learning does. So in unsupervised learning, there are three techniques: clustering is what which I have mentioned below, and then it is association, And then finally, dimensionality reduction. Clustering is actually based on the input data. We will be clustering and finding the patterns hidden in that data. So we can just uncover what are the data what are the patterns which are hidden in our data, which we can't able to see with our actual eyes, but the models can just actually view them. And association is what we have been using association of day-to-day life. Like for example, in the Amazon, if you buy a product called bread, then actually either butter or jam or some relevant products will be just recommended based on the product which we have just bought. So it is called as association, which means that how bread and bun, how bread and jam are actually associated with each other. So those kind of association rules can be found using the supervised learning. And then the dimensional direction. So in our previous use case where we have utilized the gender and age for predicting the status of the loan. So here it is an actual simple use case of just classifying only gender and age. But there comes some use cases where we have more number of features like the 10, 20, 30. As the dimensions increase, the dimensions can become an actual curse to the machine learning model. Since if we try to increase the dimensions, our model won't be able to capture the proper relationships and patterns hidden inside the data and also the actual information carried over the particular data. So for this, we would try to reduce dimensions by implementing some algorithms like PCA, LDA, principal component analysis. So those kind of algorithms can be utilized to just reduce dimensions of our data. So this is what unsupervised learning. And the third comes is the semi-supervised learning. Semi-supervised learning is a combination of both supervised and unsupervised learning. So in this type of learning, a small amount of data will be used under an unsupervised learning portion, and then a huge amount of unsupervised data will be used for unsupervised learning. And then comes the reinforcement learning. Reinforcement learning is again a machine learning model, but the output from the machine learning model will be rewarded with some rewarding system. So based on the output from the reinforcement learning model, the model will be getting some sort of rewards, and based on the rewards, the model will just act upon to the reward and then fine tune its parameters, and it carry over to the next iteration and so on. Hey, I hope everything is clear to you. If anything just matters what I have just thought, you can just comment in the chat box. Thank you.